Good morning and welcome to the audience. Today, the lecture on the topic of disaster classifications covered under the course of Disaster Preparedness and Planning Management, and the course code is U18Pcce701. The disaster is classified under two major heads, that is, a natural disaster and the man-made disasters. So the classification of disasters is related to the natural activities as well as the commitment from the human beings. The natural disasters covers the flood cyclones, earthquakes, coastal and soil erosion, landslides, volcanoes, tsunamis, things like that. Man-made disasters, the oil slick in the sea because of the bursting of the oil liners, industrial pollutions, nuclear radiations, chemical spills, artificial and urban flooding, terrorist strikes, and so on. Now, we'll go one by one more deeper into the subject. So first we start with the flood. Then we'll probably cover the cyclone also in this lecture. Floods. What is a flood? How do you define a flood? If you look at it, a flood is an overflow of water that submerges land that is usually dry. The land is dry. If it is covered by the water, you call it as a flood. Flood can look very different because flooding covers anything from a few inches of water to several feet. A very deep lake-like water or a sheet of water, all are considered as a flood. Floods are often caused by heavy rainfall, rapid snow melt, or snow surge from the tropical cyclone or tsunamis in coastal areas. Now, you can go into finding out what are the causes of the flooding. Then we can cover it up one by one also. What we are going to see is on the floods, flood management, things like that. Floods. How do you define a flood? A flood is an overflow of water that submerges land that is usually dry. A dry land is covered by water with some height of water. You call it as a flood. Flood can look very different because flooding covers anything from few inches of water to several feet. Floods are often caused by heavy rainfall, rapid snow melt, or storm surge from a tropical cyclone to tsunami in the coastal areas. Causes of flooding. Causes of flooding is obviously known. It's a heavy rains, or the simplest explanation of flooding is heavy rains. Overflowing rivers, broken dams, urban drainage basins, or storm surges, tsunamis, channels, lack of vegetation, melting of snow and ice in the tropical, maybe in the polar regions. So these things are causes of the floods. The factors contributing to flood is the rainfall intensity, obviously the major contributor, then rainfall duration, topography, soil condition, ground cover, how it is being covered. These are all the factors governing the flooding. Then mechanism. The basin characteristics and hydrological response is one of the mechanisms for the flood. Flood frequency analysis, case studies of the floods, response to floods, floodplain management solutions. We'll slowly go one by one. What is it? And then try to understand certain things. Stream order and flood response. That is when there is a catchment area is there. When rain falls on that, then obviously it attracts some of the water and it is channelized and sent it to the river. When the spreading is uniform, then there is a variations of the flow of the water in the river. For example, in this case, the water reaching from the other places to here, it will reach here, then from here, it will go here. But water which are being spilled on this, then it reaches here immediately and flow starts. So flow starts from the beginning and it's go on fed by the catchment of the rain from the other areas also. With the result, the quantity of the water flowing in the river goes on increases, touches a peak value, and then it goes down. During the rain, some of the rainwater is being absorbed by the portions of the soil and they are percolated into the soil mass. So whatever the water is going into the soil is also the seeped into the soil and most of the water is being absorbed by the earth. When there is a first rainfall is there, almost all the rainfall has been absorbed by the earth. So the flow of the water is having a small peak and then it dies down. But when rain goes on continue on the same catchment area, when there is a first rain, second rain, third rain, the water inside is locked in or the area is soaked very well. So whatever the water spills on that, not necessarily is absorbed by the subsoil and it ends in the runoff. So when there is a fourth rain on the same area, the quantum of the water flowing is very high. It's having a very high peak and it stays for some time, then it dies down. That is the nature of the flood. Not only that, and regional climate flood response is also partly contributing to the flood in the river. For example, an arid region, the flow is peak, touches a peak and fall down. If it is an humid region where the humidity is very high, then it will be touching a very small, but it stays for a longer time and then it dies down. That is one of the climatic conditions which is related to the floods. The other things are, for example, geological substrata and flood response. If your substrata is a shale, a type of a stone, a sandstone, a limestone, limestone normally absorb, then sandstone also absorb. Shale will not absorb the water. So whenever there is a rainfall, it touches a peak, and when the rainfall touches a peak, it touches a peak flooding, then it slowly dies down. But sandstone absorbs some of the water which is spilling on the sand material, then it absorbs. Peak will be less, but it will be slowly dying down. It's a limestone, it will be absorbed for some time, the water it will absorb, then afterwards it will reflect. So the water will be go on increasing, the flood will be go on increasing, touches a value, then afterwards it will not go down, it stays for a same amount of quantity of the flow is retained for a longer time. That's another characteristics of the geological substrata of the flood response. Then we have the basin geometry and flood response. If you have a spread catchment area, your flooding will touches a peak and then comes down. If it is a spread over the longitudinal direction, it touches a smaller peak, but it stays for a longer time. If your catchment area is lengthy and only one tributary, each tributary contribute to the main river, then it will touches the very high peak for some time, it stays for some time, the characteristic changes. So the flooding characteristic changes because of the basin size, basin geometry also. So these are all the factors which are contributing to the floods. Then land use and flood response. Forest area, because lot of the green vegetations are being stopped by the water, so you have a different characteristic of the flood. When there is an agricultural, it's a plain land, so it is been man-made plain ground, so it will reach us, all the water will reach us at the same point. There is a peak, it touches and die down after some time. Urbanization, it touches a peak abnormally, wherever it is stopped, it touches, then it touches a peak and then fall down uniformly. That is the characteristics of the flooding. When there is a water flowing in the area is spread out, then the height of the flooding is less. Suppose if your water flowing area is a narrow gorge, then the height of the flooding will be enormous. This D will be smaller if it is a plain. So flood plain morphology is also contributing to the effect of the flooding. Flood frequency analysis. If you see the flood, every year there will be some flood, some amount of cubic meter of the water is being flowing in the flooded area. Maybe some year, some 2630, 1980, 2020, 1981, 21, things like that. If you collect all these informations and tabulate and then see, you will get some fact you can bring it out. That is, if you look at maybe the maximum quantity of water in each year, then number of times it's repeated. This number of times and the quantum of the water which enter into the flooded area are very important. If you look into this, for 1020 cubic meter of the water for 2 times comes in that area. 1050 4 times, 1880 8 times, 2150 9 times. Very large flooding water is flowing for 1 time, 2630. Most of the time, what it tells you is, most of the time the area is flooded with the water of 2020 or 2000 cubic meter per second. Other times, maybe in very rare occasions, you will get maybe a 2630 where flooding is very high, but it may be repeated for 1 time. So most of the time, the flooding is only for that, and that is represented by the distribution curve like this. Maybe 68% of your time is being distributed with a 2020 cusecs of the water. But there are occasions where maybe 4 or 5 occasions where a very small or a drought condition, very small quantum of the water is flowing, and that represents this side. But there are other occasions where when there is a flow of the water is very high, maybe 1 or 3 times, it is represented by this time. So the dangerous part is only this part where very high cubic meter of the water is flowing on a very rarely occasions of that. If you plan for that, then you attack the floods. You rehabilitate the people, or you are handling the people against the flooding. So if you can, most of the time if you plan, then most of the time it will not be flooded. So you will get 12 to 3 times if you plan for this. Most of the time they will not. But there are rare occasions where flooding is possible. If you can plan for that, if you can put an information to your people to protect them, then you can handle the floods. That is the meaning of this curve. The summer monsoons. During summer also, there is a monsoon will be setting up, and sometime, say from the Bay of Bengal, northeast will set for India, but there are Arabian Sea monsoons, maybe in the June, July, which is summer for the Coromandel coast of India, then they are called as the summer monsoon. You get sometimes heavy rains during June, July periods are also there. So those things also you should be able to understand and handle for that. So recent floods, papers were commenting. So the Prime Minister Mohan Singh during those days, maybe flooding in the North State. The Army, Navy has been deployed. Waterborne diseases spreading. More than 300 people lost their life. And more than 5,055 people have lost their life during 2008. And these are all BBC news from 12th of August. So millions of people homeless. So these are all the informations regarding the floods you get it from each country about it. So the drought and floods are contradictory when there is a summer monsoon, when there is a unpredicted monsoon is there. For example, one monsoon happened in the Gujarat as well as in the West Bengal. Then West Bengal flooding, Gujarat flooding. All those things we should be able to handle it if you know how many times it is being flooding in that area and how best you can handle that. That's what the flood informations are giving you. Those are all the critical point where you have to handle for it during the unpredicted monsoon time, where the rainfall may be around 300 mm or something like that, 30 centimeters, then you should handle that also. So monsoon flood, the cause is intense, long-lasting seasonal rains causes flooding of intensively populated floodplains and delta in South Asia. Then second cause is hill slope deforestation in headwater reduces the soil water storage capabilities. Irrigation of agricultural causes silting of channels, reduces the flood storage, global warming, and so on. Whatever the ecological balances is not being met with, then you get the monsoon floods, sometimes pre-monsoon floods also. That is about the floods. Then comes the cyclone. What is cyclone? A cyclone is a general term for weather system in which the winds rotate inwardly to an area of low atmospheric pressure. That is, a swiveling wind or a rill wind is swiveling from the tangential side, a circular wind which ultimately touches the eye of the circles. That is the low pressure, atmospheric pressure, where it goes and falls down there and loses its pressure. So a cyclone is a general term for weather system in which winds rotate inwardly to an area of the low atmospheric pressure. For large weather system, the circulation pattern is in a counterclockwise directions. In the northern hemisphere and clockwise direction in the southern hemisphere. So your hemisphere is divided into northern hemisphere and southern hemisphere by the line of the equator. The equator line is separating the full sphere in the northern hemisphere and southern hemisphere. What it says is the largest system of weather system, the circulation pattern in the clockwise, anti-clockwise direction in northern hemisphere. Above the equator, your cyclone is in the clockwise direction. Below the equator, the southern hemisphere, it is a clockwise direction. So most of the countries in the northern hemisphere, including India, so you get a counterclockwise direction of the wind in cyclone period. The impact from the cyclones extend over a wide area with a strong wind and heavy rains. This cyclone, because it is developed because of the low pressure, it always collects the clouds along with that, and it causes the rainfall also along with the wind pressure. So there is a heavy wind flow along with the strong wind and heavy rains. Both are combined with a heavy flow, and then it causes the effect on the earth. We call it as the cyclones. However, the greatest damage to the life and property is not from the wind. Please remember this. The greatest damage to life and property is not from the wind, but from secondary events such as storm surge, flooding, landslide, and tornadoes. What is storm surge? We are going to see it. Flooding, we have already seen it. Landslide, we have to cover. Tornadoes, we have not talked so far about it. So cyclones causes some storm surge, flooding, landslides, and tornadoes. These are all the things which causes the damage to the property and men and other equipments, but it is not the real form of the, it is not from the wind. So if you see a cyclone in the India, which is in the northern hemisphere, you see a counterclockwise cyclones. So normally the cyclone which are generated in the Bay of Bengal are in the form of the anti-clockwise directions only. And that is the whirling wind, because we are in the northern hemisphere. But if you strictly speaking, but how the wind current in the earth, you can see it is quite contradicting, very interesting. If you look at, this is the equator, if you see the flow of the air, or because of the temperature variations in the earth, so there is a flow of the air which goes and touches the northern hemisphere. It goes and touches the northern hemisphere. It goes and touches the northern hemisphere. But some in the Pacific Ocean, it can come down also. When you come into the southern hemisphere, most of the occasions, it touches the southern pole only. It touches the southern poles only. But wind directions is always going towards the northern. But cyclone, when something is forms in this area, it is in the counterclockwise direction. Please make a note of it. It's quite interesting to understand that storm and then wind. When the wind blows, it is from the above the equator, it is in towards the northern hemisphere, it is on the clockwise direction. But when there is a drop of the pressure in some places of Indian Ocean or maybe in the Arabian Ocean, then the flow of the air in the reverse direction, which causes the cyclone. So you get an anti-clockwise direction of the cyclones. And that repeats when you coming to the southern hemisphere, the flow of the air is from the equator to the southern hemisphere. When there is a cyclone happens, or when there's a drop in pressure happens, then the cyclone forms in the clockwise directions. So they are all quite interesting signs about the storm and cyclones. And that is the form of the cyclone. If you look at it, the circulation pattern is in the counterclockwise direction in the northern hemisphere. So this is the part of the cyclone in India also, because we are also in the above the equator part of it. But if you go to the Australian or South African region, where it is in the southern hemisphere of it, then you get the counterclockwise direction of the cyclones will be there. That's a clockwise direction of the cyclones will be there. Sorry. This is in the counterclockwise, and this is in the southern hemisphere. You get the southern hemisphere, you get the clockwise direction of the cyclones. Please make a note of it. Record this in your mind, because when we go to the next slides, the record in your mind will be useful for you to understand more subject on that. We said storm surge. Storm surge is one of the phenomena of the storm and cyclone. The storm surge, when there is a wind blow, if in this direction, then the normal wind, if it blows, this is the tidal part of it. But then when the wind blows at a very high speed, then the top surface of the sea jumps over for bigger tides. When it touches the land, it touches over the ground and jumps over the ground, and it enters into the land. You call it as the storm surge. The storm surge is the spilling of the water over the land area because of the heavy current of the wind, and heavy tides formation because of the pressure changes in the wind also. And that's why you call it as the storm surge is also a dangerous effect on the part of the cyclone is concerned. If you look at the effect of this, it will be very disastrous to look at it, maybe dangerous also sometime. If you look at some of the storm surge area, this is the water which has been entered into the coastal area, maybe somewhere in the Gujarat area or somewhere, I don't remember that. When there is a storm surge enter into the land, it just stays there for more of the time, maybe for 4 or 5 days. It may be a salt water, and it will be very difficult for you to handle such salt water, because waterlogging will spoil even the drinking waters also. So storm surge is very dangerous and very difficult to handle also, and a lot of people suffer in that. Another occasion also you can see, when there are offshore structures are there, maybe the oil tankers, or maybe sometime nuclear power plants, or maybe sometime the thermal power plant, or maybe a super thermal power plant where the seaport are nearer for the coal transportations. Then in such power plant structures and oil jetties, you get entering of the sea into these structures, and it stays there for a longer time and many days, and it will spoil a lot of the work activities as well as incur some of the loss, because the seawater can cause a lot of damages in the land area. So that is the effect of the storm surge. And sometime if it touches the land, not necessarily the water has to enter. The air pressure itself will suck most of the material on the surface of the air and uprooted, and most of the thatched sheds and lightweight structures will be removed. The roof part of the structure will be removed totally, and you see a devastation of the land where the human habitation was heavily affected and heavily spoiled, which incur a heavy loss to the country. That is the effect of the storm, and the country incur a heavy loss, and which is economically it's affect the country also. And lot of the funding is to spent on this, and which is economical loss for the country. So storm should be handled in a proper way, and it is a part of the civil engineer's job, because the environmental science we deal with that. So sometimes the disaster causes a man-made structures like this. A railway road, a railway track have been washed away because of the storm surge. Flowing of the water over the railroads can wash away or take away the materials which are underlying over that. So the railroad spoiled because of the storm surge and overflowing of the water on the structure, on the land, or all the area. Sometimes it's wash away the people and also it wash away the structures. These are all the effect of the storm surge. When it wash out, making ready of these lines will take even 15 days or a month time. The rail traffic will cut. The revenue on the rail will be lost, even though the amount of the money they spent on the railway is already there. The dead investment is already there on the railways, but still they are not able to use it because of some part of the structure is being spoiled by the storm surge. These things are very carefully we should note it down, and because the storm surge handling is also an important factor. So, understanding the storm. So, if you want to have some of the statistical data about the storm, you see Bangladesh, 3 lakh people have been dead. And if you see India, China, everywhere, most of the country people are dying because of the storm. It's very risky affair, and it should be noted as an engineer, it should be attacked. Even though the storms and cyclones cannot be predicted, but the effect which causes is very dangerous, somehow it should be handled. At any cost, you should have the capacity of rehabilitation and also uh, minimize the cost of the investments. How do you handle that? So understanding cyclone. There are analytical modeling are there and numerical modeling there. Analytical modeling is not possible without making major simplifying assumptions in hydrodynamic equations of motion. This is by Das 1981. And he also given the numerical modeling by various people how to mathematically represent the cyclone. The analytical model, you can frame some equations because you can have the pressure you can measure the direction, you can measure the velocity, so many things you can measure in the storm. You can frame an equation for that. An analytical model may be possible for you to construct, but numerical modeling and making this analytical model numerical modeling is very difficult because numerical modeling will be end up with maybe some higher order mathematics. So closed form solution is very difficult for getting a solution in the analytical modeling. You have to sort for numerical modeling. So numerical approximation is required. So how do we do it? How we are doing is very highly mathematical, which is not covered in this syllabus. But anyway, a small knowledge is given on this analytical modeling and numerical modeling with some salient features. For example, if you want to understand the cyclone, the analytical modeling, different modelings are there. Ocean modeling is there, dynamic storm modeling is there, wind stress associated with cyclone equations are there, storm surge model equations are there. Then you are not able to get a solution, you go for the numerical solutions. For example, if you take the ocean modeling, you will get a differential equation like this, where rho is the density of the air, pressure with respect to radius of your cyclone radius, and Ks is the air friction, velocity, phi is the angle at which you want to attack, and V is the velocity with respect to radius. And Kn is the normal friction, this is the tangential friction of the air, and phi is the angle of the attack. So V is the velocity on the circumference, F is a function of the velocity. So this is a form of a differential equation for ocean modeling. If you see dynamic storm modeling, you get more continuum equations and maybe around 6-7 differential equations you will get. Then if you want to find out the wind stress associated with cyclic equation, you get another 7 to 8 equations like that. Then storm surge modeling equation, you get another 10 equations of like this. Now all these equations we have to attack. So it is very difficult to get a closed form solution, and you have to apply a boundary condition also for that to get a solution for that. But using a boundary condition, all these equations, you can numerically deduce a solution to get an approximate method using the finite element analysis. Numerical solution this numerical solution is slightly different from finite element modeling. Anyway, I will go into that 1 or 2 steps. I will explain to you what that. So if you look into the ocean modeling, it's a real ocean, you get a differential status of equation. Then Idealized approximations based on the experience and understanding of the problem based on the behavior of your ocean. Then you can have the real ocean model you can get it. That is based on your experience, the ocean parameters can be changed and you get the real ocean model. Then you can abstract symbolic representation based on mathematical experience. So some of the unwanted things or less important things can be stripped off, and symbolic representation based on the mathematical experience, we can possibly to deduce it. You arrive at a mathematical model. Then solution based on the mathematical experience, numerical mathematical experience, you can get some solutions. Results, you can analyze it. Then you compare with a real ocean model whether what all the things you are getting as per the results are matching. Then you iterate it. Again, idealization, real ocean model develop, abstract symbolic, mathematical model, solution based on results. Just go on doing. How many cycles till you get the accurate value? How many times you have to repeat it? Nobody knows. Because the real ocean model is highly a fictitious model. Because you have to achieve the real ocean model for each one cycle. And those things you have to put into the database to protect the people. And each one is a one problem of its own, not necessarily no problem is repeated on cyclone is concerned. So the numerical mathematical model I said, it is not just like a finite element method, it is called the computational fluid dynamics. A computational fluid dynamics is a very cumbersome numerical solutions, and it has to run. And lot of parameters need to be controlled. It is not just a stiffness method or any of the methods, slope deflection method, things like that, where you have a limited parameters to solve it. So you need a supercomputer to solve the computational fluid dynamics when you're coming to the ocean modeling. And it will take, even the supercomputer will take even 2 or 3 days to solve get a 1 or 2 cycles of this to get the convergence of the solution. To get the convergence of the solution, you have to have the grid patterns of very large size. In finite element analysis, normally we have a grids of very smaller size, maybe a millimeter size, centimeter size for the stress concentration. But when you go to the ocean modeling, your grid size may be around 3 to 4 kilometers is one grid size. So it's just a mammoth work or the very, very magnificent work. So if you see the grid patterns of the finite difference grid, you see maybe a u is the initial velocity, v is the final velocity. So final velocity to final velocity grid itself is 5 to 6 kilometers. In between, you get the phi, the angle of attack. So this is a grid pattern of the computational fluid dynamics. You have to solve for this. And each one will have its own numerical approximations, and you have to solve with the boundary conditions to get the solution for it. Highly a mathematical one, you need an expertise on that, because that is not scope of in this syllabus. But anyway, please try to have a knowledge on this. It is done on the computational fluid dynamics with a very large grid pattern of 3 to 5 kilometers in size. And when there is an animation of the Orissa 1990 cyclone hits it, it was taken up, lot of the measurements have been taken up. It is analyzed from the ocean, and how it attacked the area of the land in the Orissa is also being exploited. And that is the grid pattern of this is the low pressure area, and this is the formation of the cyclone. And this we call it as the storm surge. When there is a storm happening here, it will be making the tides very high level, and it makes it to flow inside the area. These white patches are the very high tides, are the storm models. So when it starts swinging, then it will goes on move in the directions. So the pressure is important, the direction of movement is important, velocity is important, everything is important in that. And angle of attack is important, low pressure is important, maximum pressure is important, low velocity is important, high velocity is important. So if you look at it, it slowly goes, it slowly goes, it slowly goes. And that's how the path is being idealized, and it is being identified by the finite element analysis. So it is slowly going and it is crossing the land, it touches the land. High wind, high tide is also going and going across the land, and that's how it goes. So that is the real path of your cyclone. It starts maybe somewhere here and it goes there. This is another, it's not on Orissa, it is on Masulipattnam. So after the Ongole and Masulipattnam, it crosses, you need to have to trace out this path. And this path, if you can predict, that's what the finite element analysis done there. If you can predict that using the finite element analysis, if you have a low pressure at some part here, for example, some part here, then your Ongole and Masulipattnam should be given a warning, maybe 5 days earlier. Suppose some part here, then you have to give a Orissa a warning. So this map is very, very important to handle the cyclones. And this should be in a database to handle and to protect the community from the disasters of the cyclone. For example, these are all the database what we have already there. When there is a low pressure here, it will cross us, maybe crossing the Madras area. Maybe suppose if there is here, Vizag, maybe in between Vizag, it can cross us if there is a pressure. If there is a pressure, then it can cross us Myanmar, it can touch us. When there is a Bay of Bengal here, it will touch us Gujarat here. Some cyclone need not touch us the ground area at all. When somewhere in the Pamban region or ocean, Indian Ocean, then it can touch here, maybe that Nagapatnam, which is one of the seriously affected by the area. There are certain parts in India are affected by this part. This is a Nagapatnam, Pondicherry, and Madras is not affected, but Ongole and Masulipattnam and Vizag is not hit by, and very rarely Orissa hit. Then it touches straight away to Bangladesh. Bangladesh is one of the targeted by most of the cyclones because it touches there and it goes there and dies down there and created havoc. And Bangladesh, some part of the Bangladesh is below the sea level, so they face a lot of problem because of the cyclones. And it is very, very important for us to understand the cyclone, and that is the signs of cyclone.